Welcome to the DIY3DTech.com channel.
Welcome to this edition of DIY3DTech.com. In this edition, we're going to take a little bit of a look at a challenge of doing some advanced aligning of a K40 type Chinese eBay laser, if you will. So one of the things on the K40 form I had covered in a prior video was aligning the bed, etc., and some of the challenges with that. And some of the members kind of threw out a piece on laser aligning. What if we could laser align the bed? So one of the things I kind of took up this challenge because I think it's kind of a interesting idea, because I really want to get this whole thing dialed in. And a couple of the big challenges that we have with this is obviously the sheet metal frame is far from being true, and there's no really substructure that holds this all square. So one of the big things that I did is I came up with this little gizmo, this little red thing here. Basically it's 3D printed, and what it does is it clips on this mirror holder, and then it holds a laser basically at a 45-degree angle. Now I'll put this up on Thingiverse. It doesn't take too much to print. It's not overly complex. I'll also see if I can't put the link. I bought like 12 of these little small laser pointers, 3-volt laser pointers, and so got this mounted inside there. And so basically all this thing is a very tight fit on here. So I made this rather small, so you'll probably have to trim it a little bit to get it on, especially as the plastic expands. I wanted it to be that way because I want it to be tight. Same with the laser. I had to clean out the hole a little bit, but again, I want this tight. So and so I did get it that way. Now for the power, what I did is I just repurposed a USB cable from an Arduino. I've got tons of them laying around, so just cut it off. And then what I did is I put a 220 ohm resistor in line with the laser diode to knock down the current, basically using Ohm's law. So I've got basically I think it's 3.3 volts or something this takes. It's got a built-in regulator right there. So anyways, this actually all works pretty good, and power is up. If I turn the computer on, basically I got the computer in the background. You can hear it beeping, and then you can see it power on, and if I put my finger in front of it, you see, yep, I think you can see the beam there. And so basically what this does is this beam is should be perpendicular to this tube. Now, one of the pieces, while it's a little bit dark in there, I think you can see it. Let me get this scale. However, this bracket is important to see, and it's kind of hard to get in there, because if you can see, this bracket is at an angle. It's not square actually to the tube, and part of this is to adjust for the the alignment of the gantry inside there, because it's not perfectly square. Again, you really have to watch my last video, and I'll explain all that in a second. But now that we have this laser now supposedly perpendicular, what we need to do is go around and take a look at the bed for a minute. So I'm going to switch around the camera angles to look at the bed for a second. Okay, so you see here I've created, taped basically a cardboard target to the gantry, to the X gantry. And then basically what happens is you can see the beam on there. Watch as I move the gantry. So it's kind of hard, but I think you can see the beam moving before it. So what I did is I marked where it is at the end of the rail, and then I basically marked where it is at the center of the rail, and then this far mark that you see on the very far end, see that one right there? That's the mark all the way to the front, and I had trouble getting in my hand in there with the pen, so I just made the vertical scribe. But you can see how it moves, and this is the problem. Is the bed is out of alignment. The actual whole gantry configuration in here is out of alignment with that mirror. So as this is moving back and forth, you can see that this is moving. And now I've twisted the gantry a little bit to show this, but mine was out probably this much in the original configuration. Also, watch how the beam dims as it moves. So this is what's happening to your beam. So this is when the laser gets to the far end here, especially if you've enlarged the bed, is why you have problems. Is basically the beam is being attenuated. See how it's attenuated? And as I get back up here, because the sweet spot is right in the centerpiece, right where that clamp was. However, now with it removed, but we can fix this. And I think, I'm going to break this up into at least 2 videos, because again, I want to talk a little bit about the dynamic, because I'm already getting on about 5 minutes or so in this video. However, I want to show you that. So now I want to show another piece. So I'm going to switch the camera angle around a little bit. Okay, so now we're back looking inside the bed. So basically, if you watch the other video where I did this comparison, where I took my scale, my machinist scale, I flipped this around so the clip is to the back, and then I have this piece here and measured to my sheet metal. And then I went to this far end and measured, and you see how far this is off? This is probably a good 1/4 of an inch off between these two, between down here where it's flush. So this basically means the bed is running this way. And this is one of the reasons that we're getting that motion, is because this whole bed area is not square with that mirror. Now, one of the other pieces that I want to point out too is this mirror, and let me pull it back here, is also very similar to that. So we can adjust the squareness of this mirror also. So the idea behind this kind of jury-rigged setup between this mirror and that mirror is because of the poor tolerances. Because in the more expensive lasers, there's, at least the ones I've seen, there's like a superstructure that holds this really square, because obviously the more square, the better off it's going to be. So what we're going to do in the next video is basically what I'm going to do is I am going to square everything up, which is going to put it way out of alignment. So I'm going to square this, because what I'm going to do here is very similar. Because if I take this and I put this guy on here, then I put him on here, I'm probably, that's pretty close. I'm probably about a 30-second off from this. And again, one of the things to remember that all this sheet metal is probably not square, and this is just a piece of stamped sheet metal that's bent. So there's no guarantee that this is perfectly square, but at least it's a good point to start with. So again, what I'm going to do is I'm going to square this up, because you notice from prior alignment attempts I put index marks here, here, and here on here to kind of get this setup somewhat aligned. But what I'm going to do is go back and again I'm going to square this one up. I'm going to square that mirror in the back up. And then what I'm going to do is I'm going to take this bed out, and I'm also going to loosen this gantry and square this up. And once this is all square, then what I'm going to do is come back and I'm going to look at how my target is hitting. And then from that, I'll see where I need to go alignment-wise. Now, in a way, that should put me somewhat close. I do expect for this to be a little bit out of kilter in general, because again, the sheet metal is not square, and this is what's holding the tube, because the other piece is the tube is probably not totally square either. So there's going to have to be a balance between the squareness of how the tube is mounted in that sheet metal chassis versus it intersecting the primary mirror, versus it hitting the secondary mirror, versus it coming into the head. So I know this gets all kind of a little bit heady, and I mean there's a certain amount that, and this is why I'm labeling this advanced alignment, because this will probably take quite a bit of time. And again, that's why I'm breaking it into 2 videos. So this first video shows the alignment device, which again seems to be fairly stable. I mean, again, if you want to be perfect, it should probably be milled aluminum and that kind of stuff. But the plastic, the ABS, seems to come out good. Printed that on the 3D printer. Again, I'll put the files up on Thingiverse. But I did want to put this video out to see what folks think and kind of give them an idea of what I'm doing or what can be done. And then, again, once I do all this stuff, I'll come back and I'll video it, because I really don't want to go through videoing me doing it, loosening it, moving it. I think you all pretty much get the idea, especially if you're an advanced user of one of these, about how everything gets loosened. Now, one of the things, just as a recap, I did put number 8 screws, replace the 3/8 bolts with number 8 screws, which has given me a lot of latitude to move in the in this bed axis. So I can actually shift this whole gantry by about 1/8 of an inch. So this is what I'm going to do, is loosen these up again and move it around and get it straight. And so that's one of the things that up front I would probably suggest, if you're looking at following, is taking a look at changing out these bolts. You know, again, something equivalent metric would probably work, but I didn't want to re-drill the hole, so this is what I did, is replace that. Okay, I can't think of too much else. I may do up a little bit better target with actually print out a small ruler and tape it to here or something, you know, print it out to get an idea how far off I am, because if I come back here and measure this from front to back, I'm probably off pretty close to 7/8 of an inch between center to center to those lines. I'm probably off a good 7/8 of an inch. So this tells me that my alignment from here to this mirror, to this target of this bed, of this bar, is 7/8 out of alignment. So basically, I've got to come back that way. And if you notice that, if I take this, and this is probably good, I'm kind of interested to see myself a little bit. So if I am, this is getting, so I'm a little shy of 5. So I'm pretty close. So if I square this bed up, I'm going to be pretty close, but I'm not going to be perfect. There's not. I don't have 7/8 of an inch difference here. It's hard for me to see at this distance with my reading glasses on. But if I'm square there, I'm basically 4/48, and here I am basically 4/38. So I'm definitely, I don't have 7/8 of an inch play in this bed, moving it back around. So where am I going to make up that difference? Part of it's going to be in this mirror, and part of it's going to be in the primary mirror this way. Because remember, I showed that is set at an angle. So between the primary mirror, the secondary mirror, and the bed, I need to get almost 7/8 of an inch of play to make sure that when I run this back and forth on this card, this laser beam does not move on the card. So anyways, like I say, again, that's why I'm titling this a little bit advanced, because this is going to be interesting. However, after I finish with this should be pretty well dialed in at the end of the day. So anyways, hopefully this kind of sets you to thinking about some stuff, and if it did, hey, please give it a thumbs up. A like always helps us make more videos like this. Subscribe to the channel. There'll be a lot more coming. There'll be a part 2 to this that I'll produce in the next day or two, because again, I don't really have a couple hours, or it might even be more than that, to donate to doing all the adjustments tonight, but I did want to get this video out. So tomorrow I'll work on doing some of the adjustments and see if I can't get it out and see how it comes along. Anyways, cheers, and see you in the next one.